Stars begin their lives when hydrogen fusion ignites in their dense, hot cores. Once that process starts, it's game on. The gravitational pull of all the mass of the star tries to squeeze it down into a tiny point, with the energy released by fusion pushes outward, creating a delicate balance that can persist for millions or even trillions of years. Today we will discuss with you the topic, how do stars die? Welcome back to Signature's Life, and you're watching Signature's Science. Small stars live an incredibly long time. Because of their small stature, they don't need a lot of energy to balance the inward gravitational pull, so they only sip at their hydrogen reserves. In a bonus boost, the atmospheres of these stars constantly circulate, pulling fresh hydrogen down from the outer layers into the core, where it can fuel the continuing fire. All told, a typical red dwarf star will happily burn hydrogen in its core for trillions of years. Not too shabby. As these small stars age, they steadily become brighter until they just sort of vaguely sputter out, becoming an inert, boring lump of helium and hydrogen just hanging around the universe, minding nobody's business but their own. It's a sorrowful fate, but at least it's a quiet one. When the massive stars in our universe die, it's much more violent. Because of the increased bulk of these stars, fusion reactions need to happen much faster in order to sustain the balance with gravity. Despite being so much heavier than their red dwarf cousins, these stars have much shorter lifespans. Within only a few million years, they die. But when massive stars die, they go out in all their glory. Their huge size means there's enough gravitational pressure to not only fuse hydrogen, but also helium, and carbon, and oxygen, and magnesium, and silicon. A good number of the elements on the periodic table are produced inside these giant stars near the end of their lives. But once these stars form an iron core, the music stops and the party's over. All that material surrounding the iron squeezes in on the core, but iron fusion doesn't release energy to counteract it. Instead, the core contracts to such incredible densities that electrons get shoved inside of protons, turning the entire core into a giant ball of neutrons. That neutron ball is able to temporarily at least resist the crushing collapse, triggering a supernova blast. A supernova will release more energy in a week than our sun will release over the course of its entire 10 billion year lifetime. The shock wave and material ejected during the explosion carves bubbles in their interstellar medium, disrupts nebulas, and even send material spewing out of galaxies themselves. It's one of the most spectacular sights in the entire universe. When supernovas happen in our neck of the galactic woods, the explosions are bright enough to appear during the day and can even be brighter than the full moon at night. Pretty intense, and what a way to go. It's the medium-sized stars that suffer the worst fate. Too big to just go off quietly into the night and too small to trigger a supernova blast, they instead turn into gruesome monsters before finally turning themselves inside out. For these medium stars, the problem is that once a ball of oxygen and carbon forms in the core, there isn't enough mass surrounding it to fuse it into anything heavier, so it just sits there getting hotter by the day. The rest of the star reacts to that inferno in the core, swelling and turning red, producing a red giant. When our sun turns into a red giant, its edge will reach nearly the orbit of the Earth. That red giant phase is unstable, and stars like our sun will convulse, collapsing and re-inflating over and over, with each even launching winds carrying the bulk of the sun's mass out into the solar system. In its final death throes, a medium-sized star spews out its guts to form an effervescent planetary nebula, thin wisps of gas and dust surrounding the now exposed core of carbon and oxygen at the center. That core gets a new name when exposed to the vacuum of space, a white dwarf. The white dwarf illuminates the surrounding planetary nebula, energizing it for about 10,000 years before the stellar corpse cools too much to enable such light shows. While beautiful and bewildering to behold in a telescope, planetary nebulas are the products of a violent, tortured death of a star. Alluring, yes, but also haunting to contemplate.